Hi, so this is our 60 most important radicals ever worksheet, and we're looking at an assignment where you have a bunch of radicals that you have to simplify. Well, I introducing in class the idea of simplifying radicals. So this video is just going to focus on the two like skills, not why or anything like that. I want to go over that in class. So I'm mentioning then that the two skills that we need to be able to have is to factor integers. Okay, and a lot of you might remember that factoring tree. That was how you were taught to do things. So in your mind, you just come up with two numbers that multiply to get the number that you're looking for. So if I have 20, I maybe say 2 times 10, or I say 5 times 4. And either way, you will eventually keep factoring until you get down to a list of prime numbers, okay? So if I'm doing, say, 5 and 4, then I'll factor 4 because it's not prime, whereas 5 is. And so 4 factors down into a 2 and a 2. And you could say then that the factors of 20 are going to be, ready? 5 times 2 times 2. So here you go. There they are. And that's great. But the problem is that I get a lot of kids who, when you get a complicated looking factory tree, you lose the leaves. And so I'm circling all of my leaves and I can see them. And if you're good at this, I've seen students do this. They remember to circle a leaf as soon as they realize that they have a prime. So in order to help you with this task, I wanted you to know that I have an alternate way of doing this where you don't have to keep track of the leaves. I call it the single branching factor tree. And all I do is use the list of primes and do some subdivision steps. So let's make a list of primes right now. 1, 2, 3, 5, 7. Not anything even, right? Because then that's factorable by 2. Not 9, because that's factorable by 3. So I'm moving on then to 11. How about 13? Yes. How about 15? No, because that's 3 times 5. How about 17? Yes. How about 19? Yes. How about 21? No, because that's again a prime. Sorry, that's a 3 times 7, so that's factorable. 23, yes. 25, no, because that's 5 times 5. How about 27? No, because that's factorable by 3. So then I'm at 29, and I'm kind of bored of that. That's as many primes as I'm in a list, okay? So when you get to a prime number, I'm going to show you how to use my single branching factor tree. Now, I've already factored 20, so maybe that's boring. Maybe I'll pick a new number. How about I try 48, okay? And so with my tree, I just draw the one trunk, okay? And I put 48 off to the side, and I say to myself, well, what number could I divide 48 by that I would get a whole number, right, an integer, as an answer? So ready? I'm going to say 48 divided by 2 is going to be 24. So I'm not dividing by 1. That's boring. I want to go straight to the 2 because it's even. And I can always divide something by 2. And it makes your life really easy if you divide by 2 until you can't divide by 2 anymore. So at 24, I can still divide by 2. And so 24 divided by 2 is a 12. Ready? It's a 12. And if you divide again by 2, you'll end up with a 6. And if you divide again by 2, you will end up with a 3. The only trick to mine is that you have to remember to bring that last number over. Okay? So that's my single branching factor tree. And guess what? All of my leaves are right here. These are all the factors of 48. Let's go over that real quick. 48. If I take 2 and multiply it by 2, I get 4. Times 2 is 8. Times 2 again is 16. And then I take 16 and I multiply that by 3, and I will totally get a 48. So those are my factors of 48. Okay? Now, if you want to see me do the single branching factor tree, you're in luck because that's the only thing I use. I do not use the branching, the several branches tree anymore at all. I learned the single branching factor tree in my computer science class, and I find it so useful that I just don't do it the other way anymore. So all year You will get to pick which one you want to do. Do you want to use this tree? If you can, and if you're successful with it, great. If I notice that you have a hard time with that tree, I'm going to tell you, you should probably move to my tree, because my tree is just that easy to use. Now, what if you're like, I actually looked at 48 and I didn't know how to do that at all? Well, you can use Desmos, right? You can take 48 and divide it by 2 and it will tell you that you get 24. You could take 24 and divide it by 2 and it'll tell you. So just plug it into Desmos until you find those factors, okay? So that is the basics of factoring integers. And now we want to talk about what it is that you have to do for your assignment. And this is going to be, ready? The topic is simplifying um, roots. Okay, and I'm going to say more than just simplifying radicals, because we're going to learn how to do it with more than just, square roots as we move forward. So in class, I went over vocabulary, and you hopefully will recognize that I'm calling this guy the square root. And I actually, I saved it right here. You should have completed this one already, where we know a bunch of square roots. Now, you might not have them memorized yet, but I promise you that we are going to work with them enough to where you will have them memorized at the end. It's just going to be, you're not going to be able to help yourself. You're going to accidentally, memorize all of these. Okay. So I want to mention that in this list, I am missing the square root of 2 and the square root of 3. I am missing the square root of 5, 6, 7, and 8. I am missing the square root of 10, 11, 12. Do you see all the ones that are missing? That's because those ones don't have a whole number as an answer. What they have is a decimal. So we're going to work on looking at that in class. But for now, I'm going to tell you that any square root that doesn't have a whole number as an answer, it still has a chance to be simplified. Ready? I'm going to start with my favorite, which is the square root of 8. When you look at 8, if you factor that tree, ready? The tree for 8. I divide 8 by 2, I get 4. Divide 4 by 2, and I get 2. And boom, these are my factors of 8. If you think about it, the square root of 8 should be the same thing, ready, as the square root of 4 times the square root of 2. Well, why? Because, ready, 4 times 2 is 8. Oops, I wrote the wrong number here. 4 times 2 is 8. So if I'm putting in that I'm factoring out that 8 into its individual components, well, as soon as I recognize that there is a square root of 4 in there, boom, I already know, ready? The square root of 4 is just a number. It's a whole number. It's a 2. The square root of 2, that is different. That is a decimal, and you might not have that memorized. I have it memorized, but I still don't want to use it here. Ready? I'm going to leave it. The square root of 2 times the square root of 2 is what I call simplifying a square root. Okay? Now, I understand if you are in this camp where you say, hey, if I look at the square root of 8, if I look at this and I compare it to that, honestly, Ms. Shatra, I think that the square root of 8 is easier to look at. I think it's simpler looking. And I understand what you're saying. And I want to get into that when we're in class where we can have a discussion. For now, why don't we just think about what other numbers we think maybe could be simplified? And so I'm mentioning that I found this square root of 4 inside of this number, 8. And I'm thinking then that any number that is a multiple of 4, it is going to be simplifiable. So what would the next multiple be? Well, after 8, don't I get to 12? And so when I think about 12 and I do my branching tree, 12 divided by 2 is 6, divided by 2 is 3. Bring that last factor over, and this is my tree. So the square root of 12 is really the same thing, ready, as 4 times 3. And when I do it that way, I say to myself, oh, well, the square root of 4 can be broken apart into its own piece, and you can do it like this, ready? 4 is the same thing as 2 squared. So when I take the square root of it, what do I end up with? 2 out in front and a square root of 3 on the inside. Now notice how from this first question to this second question, What changed was the number on the inside. Right? Remember, I called that the radicand when we were in class. So what if I moved on then to the next multiple of 4? Well, the next multiple of 4 is actually 16. Okay. And so you might mistakenly think to yourself, well, this is really ready, the square root of 4 times the square root of 4. And then you would only do this. You'd say, oh, my answer is 2 times the square root of 4. No, I'm sorry. You forgot to take a square root. And that square root is this square root of 4. So really, this is what? This is 2 times, ready? The square root of 4 is 2, which gives me a 4. But you knew that. If your brain was connected in the right way, what you would hear when I say the square root of 14, ready? You'd have it memorized. You'd know that the answer was 4. Just like that. Just snap. It just pops into your brain. But if you don't have it memorized yet, then we're getting you there. So we're trying to get you to a place where you do have the square root of 16 memorized and you do recognize it as 4 times 4. And then you could give me that square root just in a heartbeat. But when we're doing the worksheet, that's just a little bit of a trick. I want you to be careful. I want you to think about all of the square roots that you know. And so let's take a look at the worksheet. Are there any square roots that you do know already on there? If so, pause your video and write them down right now. So in here, I know that this one is 4. In here, I know that I'm moving on. I don't really recognize any of these, but I do recognize that. That one is 8. In here, I don't know that I recognize any until I get to that one. I definitely know is 3. And you want to go through and find all of the rest of the ones that you do already know, the ones that are on this list. That way you won't get tricked when you're following the pattern that I'm about to give you. Okay? So the pattern is, and there's a cute little story that goes with it, and you may have heard me do it in class, but if you weren't there, I'm telling you the story now. That there's a saying, okay, and this is the marriage story. So when a couple gets married, two become one. And that's a story that you may have heard said, at some point, like, two people get married, then those two, they become like one person because they're married now. Yay? And I like that story and I think it's cute. So I'd like to use it when I'm doing my work. Ready? If I say that I have, say, the square root of 40, well, there's a 4 in there and I can recognize it. And I could do it the old way. Or I could do it like this. Ready? 40 divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. Bring that last 5 over. And here's what I'm going to do. I have a pair of 2's. I have an extra 2 and I have an extra 5. And what I'm using here is called the multiplication property, that all of these things can be multiplied together underneath the square root because PEMDAS says that I multiply and then I should take the square root. But when we're simplifying, we're playing a game where we're trying to find squares that we're pulling out. So we're not trying to just, factor. We want to factor and we want to find squares that we can take out. I'm going to declare that these 2's are getting married and they are leaving the radical house. And who is left inside is a 2 times a 5. But that's not my final answer. I will actually multiply them back together. That way it looks, I think, a little bit better. 2 times the square root, ready, of 10. So now we've done a bunch of them with 4's, and you're thinking, shoot, I've got this. I know all my multiples of 4. I bet you do. But do you know all of your multiples, ready, of 7 or of 9 or of 11 or any of these other harder numbers? Because when you're looking at it, if you don't recognize that something is a multiple of 16, then you won't be ready to take that out. Here, let's try this. 48 is also a multiple of 4, but is it a multiple of something bigger? Here you go. 48 divided by 2 is 24. Divided by 2. Oh, wait, we did this, didn't we? This is divided by 2, divided by 2. Last number I get is a 3. So let's look at this. Who can get married in my radical house? Do I have enough 2's to marry off? Ready? I have a pair of 2's. They are leaving my radical house, and then I'm imagining, right? You became a couple, you don't live at home anymore. You're leaving your house so that you can go and find an apartment somewhere, and be married together, right? So here we go. Two, got married, left the radical house. Hey, these guys also got married and left the radical house. Who was left outside? Ah, it's that three. I will multiply these twos back together and I will find out all of a sudden in the back of my head, I think I knew this, 48 is really the same thing as 16 times 3. And what I'm doing here is I'm taking the square root of 16 and I'm getting a 4. Now, when I write equal signs here, I'm very serious about them. This square root of 48 does equal that mess. And this mess also equals that mess, which also equals this mess, which also equals that mess. So in class, I showed you how to use Desmos to check your work, okay? And so some of you can't be in class. I'm making sure that I'm teaching you things twice. So this is the end of your notes. I've done enough problems. I think you should be able to do the rest of them. But I do want you to be able to get answers and make sure that your answers are correct. So I'm going to mention to you on Desmos here, if you weren't able to catch this in class, when you are doing square roots, you will find them. Ready? You open up the keyboard. It's this button right here. It's right down here. And I'm trying to press the button so you can see it. It's in the lower left-hand corner, right next to the sound button, right next to the ABC button. So I have square root in here. And let's say, for example, that I want to know what the square root of 48 is. Well, guess what? Desmos will not simplify for me. Okay? It just doesn't know how to do that. However, I can put in that square root of 48 and find out what the decimal is. And then I can take 4 and I can, ready? I could do square root again. And when I do, I find out, hey, those two decimals are exactly the same number. And once you see that, you know that you have simplified it correctly. If you put two numbers in and they don't match, then that means you made a mistake. Okay? And I just wanted you to know that. Now, the last piece, and this is the most important part, ready? Right here under functions and right there under miscellaneous, that is how you find a higher root. This worksheet does not need a higher root, but the next one will. So if you're still watching, I am mentioning that there is a special place to find roots other than square roots. Okay? You have a great time with this worksheet. I always enjoy doing it. I hope you do too.